Okay, in this video I'm going to be talking about the oxidation of alcohols. Now before I start, I'd just like to clarify that this is oxidation in aqueous solution using a aqueous oxidizing agent. It is not as a result of the complete combustion of the alcohol. Complete combustion of an alcohol in excess oxygen will produce carbon dioxide and water. If there is insufficient oxygen for complete combustion, it is also possible to incompletely combust alcohols to produce carbon monoxide instead. But in this reaction here, we're going to be looking at the partial oxidation of alcohols using an aqueous oxidizing agent. Now, this process, the oxidizing agent, I'm going to represent with an oxygen in square brackets. The oxidizing agent must be acidified. The presence of acid is required in order to provide the H+ ions which are necessary to balance the reduction equation of the oxidizing agent. The oxidizing agents that you need to be familiar with are the dichromate ion, so Cr2O72-, and the permanganate ion, MnO4-. Both of these are strong enough oxidizing agents to oxidize alcohols. So there are three possible pathways for the oxidation of alcohols, and which is followed depends on the position of the hydroxyl group in the alcohol molecule. If the hydroxyl group is positioned at the end of a chain, so we have a primary alcohol, therefore there are two hydrogens on the adjacent carbon and a maximum of one carbon, this could also be a hydrogen, then the oxidation will proceed as follows. The first step of oxidation involving the oxidizing agent will remove two of these hydrogens. So these two hydrogens will leave in the form of a water molecule. And the product of this process will be an aldehyde, and of course water. This aldehyde molecule can be further oxidized if it is exposed to more oxidizing agent, and it will be further oxidized into a carboxylic acid molecule. If it is desirable to stop the reaction at the aldehyde stage, then both of these steps require the same reagent, the acidified oxidizing agent. So we must change the conditions in order to arrest the reaction at this aldehyde stage. So in order to do this, the reaction is done under distillation. Heat. If the carboxylic acid is the desired product, then instead the alcohol can be heated with the oxidizing agent under reflux. And the difference here, so with distillation, the product, once it evaporates, is then removed from the reaction vessel and is condensed into a separate container and can no longer undergo reaction. Under reflux, the product condenses and drips back into the reaction vessel and will continue to oxidize until it is all oxidized to produce the carboxylic acid. So this is the oxidation of a primary alcohol where we had a single carbon attached to the carbon with the hydroxyl group. If we have a secondary alcohol is one where the central carbon with the hydroxyl group has two carbons attached to the carbon with the hydroxyl group and a single hydrogen. So here the hydroxyl group is in the middle of a chain. And the oxidation here will proceed in a very similar manner to the first step of oxidation above. So the oxidizing agent will remove two of the hydrogens, producing water as a byproduct. Only this time, the C-O, the carbonyl group, is now produced in the center of a chain. So it is not possible to further oxidize this molecule. This is a ketone. So a secondary alcohol with the hydroxyl in the middle of a chain will produce a ketone. The conditions for this, again, you need heat, you need your acidified oxidizing agent. This reaction can safely be carried out under reflux. There is no intermediate step where the reaction can be stopped, so it's not necessary to carry this out under distillation. The final type of alcohol which is possible to have is a tertiary alcohol where the hydroxyl group occupies a position at a junction, so there are 3 adjacent carbons on the carbon with the hydroxyl group. Now this molecule cannot undergo oxidation, so it's not possible to oxidize this molecule. It's possible to determine whether an alcohol is tertiary as opposed to primary or secondary, as the colour change will not be observed with the oxidizing agent. The dichromate molecule, the dichromate oxidizing agent, they will undergo a colour change from orange to green as the chromium itself is reduced from chromium 7 plus down to chromium 3 plus, and the permanganate will undergo a colour change from purple to colourless as it undergoes the reduction. So, primary alcohols, 2 steps of oxidation from alcohol to aldehyde to carboxylic acid. Secondary alcohols, 1 step of oxidation from alcohol to ketone. Tertiary alcohols will not undergo oxidation at all.